Hi, and welcome to CheeseCutter tutorial. My name is Carsten Berggren. Handle is SCAR6 of Offense, and I'm here to teach you about how to use the pulse table in CheeseCutter. So I expect you to know a little bit about CheeseCutter and how the windows are structured and how to navigate around in it, but I'll try to explain my way around anyways. So don't expect this to explain the whole editor this time. Look on some of my other tutorials about that. Okay, first of all we need a test sound, so I'll just make a simple what we call it, simple tone here in sequence 0, and I'll just enter some kind of tone. I think I'll use another pattern, so I'll say let's pattern 1 and copy Alt-C from pattern 0, which is my template, and I have made it my default length, with which is normally 40 hex or 64 rows, and I'll just add some kind of tone here. Let's say we say a symbol A3, and I think I'll put it in instrument 8. Bad habit, good habit, whatever. My volume for this instrument for test will just be C, not 8 and not F, because I want to have a possibility of adjusting my volumes when I do instruments, but for now it doesn't matter because we're just making this instrument, but I might add more instruments in the same test, so let's see how this goes. So CC, and perhaps fade out with C, it doesn't matter right now, and my last waveform byte here, I'll just point it to my wavetable and say 41, which is pulse, and 7E to stop it. And now we have the issue of trying to do some kind of sound. With this player version, which is CC4.02, you have the option of doing a little hack here, or a shortcut where you just write an 8 in the first nibble, and then you have the values from 1 to F, where 8 is the middle and thereby the most square sound, and you can say 1, and then you have a very narrow pulse, which sounds like this. And you can have a little bit more. But you can vary this one. This one will stay there, static all the way. So it's good if you need it for a drum or something where it needs to be 8, and it is this way, or you need the effect of it. But anyway, this is one way to do pulse. If you want to do a pulse program, which is this table down here, and you access that by Alt-P, because P is the gray letter here, or the white letter with a gray background. Then you write the row number of where you want to start your instrument's pulse program. That's why we call it a program, sort of program. The first free row in any new tune in this version of the player is row 1 for pulse, because the first row is occupied by some default values. Actually, these has some meaning, but don't fiddle around with them for a start. That's not recommended. It won't break, but it probably won't sound as you expect either, so don't touch it. Okay, first row here. I'll just make my instrument up here, pulse test 1, and I'll make my pulse program point at row 1, so 0, 1, like it says down here, and Alt-P, and then I'm in my pulse program. Okay, we have 4 values. This value, byte 3, if we look in F12 help, we can see here it's the initial value for the pulse, and the pulse program is made so that the most significant byte is here to the right, and the least middle significant byte or bits are here, and then there's actually a third nibble that isn't used, so you don't have the most what you can call it, a detailed way of specifying it down to a certain frequency, but this is way enough for most people. I have never used the last digit for anything anyway, so, and you can't specify it in this player, so no need for that. Let's say I want to do that 800 square. If I enter this, I get 800 as a value, like I write here. This is the pulse value for a middle, where the top will be F, 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 and the bottom would be 0, 0, 0. And if I write a 4 here, the value would be 840, where again the last 0 is something you have to imagine. So these two numbers are the ones you write in this initial value, and they are reversed. So it's a thing about how the player is optimized to work with the bits and squeezing it down into one byte. Ask Timo or anybody else, Laxity or Yoseho or somebody about why these numbers are written like this. I don't know who did this first. So anyways, this is my initial pulse value. If I play this, I get a, and that's because this row is only supposed to play for 1 frame. And a frame is the time the VIC register takes to redraw your monitor. And if you're on a PAL system, that's 50 frames per second. So it is there for 1/50th frame, and that's not a lot. Okay, the first byte here says how many frames you want to keep this sound, or rather, how many frames you want to stay on these 4 bytes. I'll explain the other bytes in a few seconds. So if I say, okay, stay there for 8 frames, we got that sound. If I say stay there for 20, which is 32, and then it shuts off. Why does it shut off? Because when this counter is done, it counts down from 20 to 0, then it goes over here and checks what's in this byte. If there's a stop value like 7F, the program, or the pulse program, what you call it, jumps to this row actually and stays here and does nothing. You can think of it as a stop value. If you say 0, it just jumps to the next row after it. And if you write a row number like I want to jump down here, then you can say I set my pulse to this and I say 7F to stop. And then I could, up here I could say jump to 8 when you're done. This will mean count 20 hex down, adding this value to the pulse each frame, and when you're done, jump to row 8. Then it jumps down here and does nothing for 1 frame, and then ends the program. Sounds like this. As you could hear, it goes very narrow after a few seconds, frames. I believe if we have, let's see, 32. Yeah. And if I said 8, and I said 8, and I said 8, and I said like, okay, let's say we made 8 here, we made 4, we made 2, and we said go to next row, next row, next row here, and stay in each row for 8. Even do some more just to make it more apparent what happens here. This way you could program and change the value of your pulse register after every frame. And as you can see, this grows pretty fast. You spend 4 bytes every time, and of course we could remove this row because we don't use it, or column, and we can remove this one if we just made those 2 for the delay and the value. This way we can program how we wanted our pulse to work. Let's say we stop here. But the problem is this isn't very fluid, so if we want a very smooth, just like a sinus, if we want this to be very smooth, we need some kind of, well, 8 frames is too much. Let's say we go down to 4. Ah, okay, that's also nice. Let's say we jump this one to the first row. The reason for the pause is that we actually go up to 8, and that's where we started. So if I remove this 8, or rather here jump to row 1 already here, it ignores this row. This is not exactly what I call a smooth pulse value. So what we can do, instead of using this many rows, now I'll just hold down the 0 key to clear this crap out. What you can do instead is say, well, I want this sound to stay for 20, which is 32 again, and I want for each frame, each of these 32 frames, I want to add 8, starting at 0, 8 or 800 pulse, which is the middle, and then go up. Can you hear it? Okay, change this to double length. Okay, let's say I put more speed into this. Could you hear it get very narrow in the end? If I say 30. And it makes a kind of a knack. The sound goes like... try and hear again. There. It's not very pleasant for your ears, and that's what I call a newbie pulse setting, because you don't... manage to stop the program or the counter before you overwrap. It's just like the sprites on the screen. If you forget to turn on the extra bit in the right side, the sprite wraps back to 0 on the left side. So you need somehow to stop before you reach the limit and start going backwards or do something different. If I press Ctrl F9 and press play again, then up here we get some debug values. And this means we can see what happens with the pulse, because these 2 bytes are the pulse. Check it out. 1, 2, 3. So it goes over 0, okay? You can actually see it in this byte. Try and look at it when it goes from 0 up to and crosses 10 here. That's exactly where it says. So we need to avoid that. So what you can do if you can't remember which numbers to use is to try and hear and try and observe what happens, and then just keep changing. So let's say I say, okay, I want to count for 40. Then I can't use 20 because that's too much. Let's say 1F. Too close. Okay. Let's say I want to count backwards now. The opposite, when I want to count down, because this value from 0 to 7F means count up, or rather stay here while you add this value. And the opposite is if you add 80 to the pulse delay. Let's say I had 40 and I add 80 more, then it becomes C. Anyone doing hex knows this. And this means counts backward for 40 frames, or 64 frames in decimal. And if I say exactly the same speed, and well, I don't know where I was here, so which value should I start at? F? Nah. E? Maybe. If I say FF, it ignores, or rather it stays with the current value in this variable. So you have a fluid way of going up and down in the pulse without thinking where you are. So FF means continue on whatever pulse value you have. And here, when it's done counting for those 2 frames, I want to jump back up in this row. So I say row 1. Now I have a loop, as in 64 frames here, counting up, 64 frames here, counting down. See, that sounds a little bit more pleasant than before. If I want to make the speed higher, I need to make my delay smaller, or perhaps start somewhere else on my so-called sinus, because 800 is exactly in the middle of the pulse. That's why you get a very square, very full sound. Let's say we started in 4. Then we could go all the way from 4 and up to 8, and across 8 all the way up to C and back. Only thing is that the values from 0 to 8 is, well, the width of the pulse on the left side of the pulse sinus kind of thing. Try and imagine a very square sinus. You have an upper part and a lower part. And I must admit, I can't recall if the first part of the pulse is up or down, so it doesn't matter. Let's say it's up. The first part from 0 to 800 is on the left side, and from 800 and the rest up to 1000 is the right side, which is low. So if you narrow down the left side, it becomes tiny on the left side, and the opposite. So when we go like this, you can see it up here. Now we count from 4, and we cross 8, and we go even. We reach B. We doesn't reach C. So in fact, we don't get up there. So we can actually add a little bit. I have no clue if you could hear me there. I said, as you can see there, it doesn't reach a C value, so we can actually do our count a little bit faster, I think. Yep. And I could make the gap smaller. Let's say I wanted to count to 20, and I said the opposite of 20, that might be 80 plus 20, that's A. Now the length of the sinus isn't that long, so now I can add some speed. I can even say 40 here. It gives this pulse value. If you want a clear sound, you need to make it smaller in the speed. And the lower frequency you use for your bass, the lower speed often sounds better. But again, if you make it too small in speed, it sounds very Apex player kind of thing, and that's not something I prefer, if I must say. Also, I normally add some kind of random value here, because if you make two noises or two sounds with a pulse, they kind of remove each other, like waves that cross each other. So I try to make the numbers go where the other number isn't at the moment to make a more full sound. So try and like if I write 6 here, I usually write 6 there also, 5 5 or whatever, and then tweak the sound in the end to hear what works. And somebody asked me if I just practice and hear a lot. Yes, I do. I keep playing and playing and playing and playing until I hear something that I think, oh, this one works. And it can be frustrating sometimes, and other times it's just pure luck. So, and of course you can go back and copy from other tunes you've made before, but for a start you just need to play around and figure out what works for you. Let's say we have this one. I would like to hear how this works on a lower octave. So I went over here with Alt1 and said, edit the octave here. Interesting. I want to see something interesting here. If I shut off this sound, let's say, and nothing happens here, I'll make a new waveform here, 41, and keep 41, 41, 41, 41, let's say 5 frames, and 40 to turn off, and end my program with 7E. I don't want to explain the wavetable, this one. I'll make a separate tutorial on that one, so, but just do what I do if you want to copy this. And this means I will play the waveform 41 for a few frames and then turn it off. And I have set a very short release, so I get this stump sound. I had hoped, at least, because I forgot to point at the wavetable. There we go. And it even has a little bit release. I don't want to release. This is okay. And now I do something called hard restart. I set 80 and I set a waveform of 9. Don't ask why, just do it if you want to copy this. Sometimes you add some kind of value here if you do it, and that's the sustain and release value. You can play around with this. I usually write F0 or 80 something. This is because I want to do a test over here. Wrong sound. This is stupid to do it this way, but... And I'll even do my sequence shorter so you can see what happens. Yeah. And yet again, I'll do my sequence longer again, because now I want to insert Alt-I, and I want to... No, not Alt-I, that's instrument casting. Alt-A, and I can insert from this sequence, which is sequence 1, and then it copies from the top and inserts here. So now I have the same. Yes. This goes too slow, so Control and minus on the numpad. Wow. Wow, that's really exciting. You must be proud now. This is not exactly interesting, I would say. Let's see, I'll just try and test some things with the instrument for a short while. I won't say so much, so just pay attention. Nothing happens. Okay, this is interesting. Now, what happens if I clear this one while it plays? And why? Because if you say 0 here, it works just like the FF value in the pulse program. It ignores the pulse program and just let it go on with whatever it is. If you write a value here besides 0, it initializes the pulse program. So 0, 0 means continue at whatever row in the pulse program you're in already. So this way you can make it walk in the pulse, but you need to initialize it, and you do that by writing a command code of 40 plus the row you want to hit it with. And I want to hit it with row 1. So I say 40 plus 1. Okay, now I'll also make a new pulse here, and I'll make it very slow. So I'll take the longest delay I can do, 7F, and I want to make it go slowly up, maybe 13, because I want a unequal number. And I want to initialize with a very narrow sound, let's say 1 or 2. I'll try 2, so remember my rule 2-2, just to make it different. You can always adjust later. And I know this won't get very far, so I'll try to make it even longer. This means that it will count to 7F, and at the end of the row, counter, it will say go to next row, because you have 0, 0, and I say do exactly the same again. Right here, I could just have pointed back to row 3, so it would stay here. Would have been okay, but I prefer to make a program I have more control of. But it depends again on if you want to spend 4 bytes extra, or you want something you can reuse for another part of your tune. It all depends on what you're doing and how you compose. Okay, instead of doing an extra instrument, I can just say, well, I want to initialize at row 3, so 43, and then we have this one too. Except that this instrument turns off immediately, so I will have to make a new instrument anyway. Forget my smart tricks here. And let's say we don't need to be hardcore on the hard restart on this one, just go like this. And why didn't I get a sound? Because I didn't initialize my pulse, so row 3. Okay, that sounds pretty okay to my ears. Now I'll try to do something different here, because now I'll turn off some of the channels, turn 1 or 2 off. That sounds pretty okay. Number 2. I can already hear the drums in my head. This could be a tune, maybe. Oh, whatever. I want to show you what you can do with this funny pulse program. So now I'll go down to pulse, and I'll say we need a narrow one, 2, 4, and 6, and the full one. And let's make them 4, 4, 2, 6, 6, blah, 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 blah. And after they are done initializing this, I actually just want to jump into the same program. So let them jump in here. And let's see, maybe I should make a new program just to avoid smacking up. Yeah, I'll do that. I'll make them all, when they are initialized, I'll make them stop jumping around cursor. I'll make this one. And I'll say jump here. They all jump to A, and in A I will make a very narrow sinus going up and going down. And I will say use 33, and I'll say use whatever value you had already, and I'll say in this row go to the next one, and this one go back to A. So here I have a little loop that isn't initialized, and I'll use these 5 rows for initializing the sound. Let's see if we can make anything interesting with this. That means if I need to use commands to hit this one, I'll go from 45, 46, 47, 48, 49. And this is where we are putting it. So let's see. 41, no, 45. Okay. 46. Why didn't that work? Oh, it did. See, that sounds like, this kind of sounds like the sound is just using a normal pulse program. What if we go from one scale, end of the scale, to another? Say 45, 49, 46, 48, 47. How's this sounding? Oh, now it stops. Why did it do that? Oh, 40. Haha, 40 means row 0, and that does nothing. Yeah, right. Again, let's just play around till you're satisfied. I think that's an interesting way of using pulse, if you need it. What else could we have about pulse programs? I think this more or less covers it for a start. I've spoken almost half an hour. Maybe this was too confusing. Maybe I'll make a shorter version, but I hope this can inspire you to use pulse programs. So let me recapitalize what's happening here. We have the delay counter. The first one counts how many frames. 1 out of 50 if you are doing PAL music, 1 out of 60 if you're doing NTSC music. That's 50 hertz, 60 hertz, that's why. And the player goes on with frames, and you have a speed down here. And the speed is also how many frames there are between it takes a new row in your music. So this speed has no influence on your pulse program. Just be aware of that. If I make this tune go very slow now, my pulse program is still doing the same tricks at the same speed. So once you have decided your tune speed, then you can start to figure out what speed you need in your pulse. If you need a pulse to go from a certain point from up here to down here, whatever your effect is going to be. So that's one way and one thing to think about. Okay, and the next byte in the pulse program is the actual value you want to add. If you notice the editor, it always tells you up here when you move between the bytes. And if you forget this, you can just press F12 anytime. And when you're done reading, just escape, and then you're back here. It also says up here, press F12 for help. Great idea, Timo. And third byte is the initial value, and it has a control value of FF, which means ignore initialization, continue on whatever value I'm in already. And the last one is, well, 00 means go to next line, continue. Otherwise you write the row number, or you write 7F to stop your program. That can also be an effect if you want to make like a meow and keep the sound. I could do that for a quick test here, but I think that's a bit boring. But let's see, should I do it? Yes, I do. Anyway, no, you can experiment with that. Experiment with that yourself. I think I'll keep this one. Call it. Let's see, where can we go? Here we can go, and we can call it. We can call it Pulse Table Tutorial 1 CT. And then we can see if you need it uploaded somewhere or you want to do this from scratch. I think you should try and do it yourself, because you get it on the fingers, and somehow it gets stuck faster when you do it yourself. So that's it for me. Carsten Berggren, Scarsex, signing off this time. I look forward to do other tutorials. Keep posting your feedback on what I'm doing wrong in these tutorials. If I'm too fast, too slow, if there's some topics I don't go into details with, let me know. I'm new in this, and I hope you'll enjoy it as much as I do. So have fun. Bye bye.